Now if I simplify the denominator, I will get 5x. Now 5 by 3 at the denominator is the constant one. To use that theorem, I divide the numerator by ax to get that standard limit and denominator by bx to get that standard limit. We are getting the standard form like this, though here the angles are ax and bx. For removing that, we have to change the variable. Now I move to the second set. You see, I have taken limits involving trigonometric form. First of all, number 8. Before solving these sums, let me mention that we have to use here the standard limit. Limit x tends to 0, sin x by x is equal to 1. Actually, in many cases, we have to simplify the numerator and denominator using the transformation formula in some cases of trigonometrical ratios. Then finally we have to use that standard form I mentioned here. Standard limit x tends to 0, sin x by x equal to 1, and don't forget that here x is measured in radian. Now I work out the first term. Limit x tends to 0, sin 3x by 5x. Before solving, let us discuss. Numerator is sin 3x, and already we have seen the standard limit is sin x by x. Here in place of x, 3x. Therefore, to get this standard form, we have to get here 3x. For that, I do this one. You see, limit x tends to 0, sin 3x by 3x into 5 by 3. Now, if I simplify the denominator, I will get 5x. Now, 5 by 3 at the denominator is the constant one. To use that theorem, limit x tends to a, c fx, that is equal to c into limit x tends to a fx. I am using that. Then 3 by 5 is the common, is the constant one. I take it out. Limit x tends to 0, sin 3x by 3x. Now we see limit x tends to 0, but here the angle is 3x. To get the standard form, we change the variable like this. Putting x equal to say y, therefore y tends to 0 as x tends to 0. Therefore 3 by 5 limit y tends to 0, sin y by y. Therefore 3 by 5 into value of the standard form is 1. Therefore, finally result is 3 by 5. Let me discuss different steps. Original one is this one. Now we see the angle of the trigonometrical ratio here. Sine is 3x. To get this standard limit, we have to get here at the denominator 3x. That is why I have written 5x as the product of 3x and 5 by 3. Now 5 by 3 at the denominator, that means the value is 3 by 5. That is constant one, and we have to use here this theorem. For that, 3 by 5 will be outside c into limit of the function x tends to 0 sine 3x by 3x. Now here we see x tends to 0 and the angle is 3x. Here we have to change the variable. I have taken 3x as y, hence y tends to 0 as x tends to 0. Use that one and get the final result 3 by 5. Next sum is number 9. Limit x tends to 0 sine ax by sine bx. Remember here a, b are non-zero quantities. A, b are non-zero quantities. Now since sine trigonometrical ratios are there, after writing that we have to think that we have to use this standard limit. For that we write the given expression sine I divide the numerator by ax to get that standard limit and denominator by bx to get that standard limit. Now what we see that we have divided the numerator and denominator by some multiple of x. Can we do that? That is the question. Answer is yes. Yes. Here x tends to 0. Therefore ax bx both tends to 0. Now for balancing we multiply it a and this by b. Now we find a by b, that is a constant. We can take that outside like this. Then limit x tends to 0 sine ax by ax, limit x tends to 0 sine bx by bx. And we are getting the standard form like this, though here the angles are ax and bx. For removing that, we have to change the variable. That is equal to a by b into limit yz. Say y tends to 0 sine y by y, limit z tends to 0 sin z by z. You see, if I take ax as y, then y tends to 0 as x tends to 0. You mention here taking ax is equal to y, therefore y tends to 0 as x tends to 0, and bx equal to z, therefore z tends to 0 as x tends to 0. Finally, we have got two standard limits, limit y tends to 0 sin y by y at the numerator, and limit z tends to 0 sin z by z at the denominator. Now we put the values a by b into 1 by 1, therefore finally a by b. That is the answer of this sum.